software, Wesley Sherwood has worked the solar generation department of his company for the past 2 years. He enjoys working in solar as it is a rewarding form of energy and a renewable form of energy, solar electrical generation. And he says it's the least damaging form of energy for the environment. Tonight, Wesley will share what is involved in generating electricity without complicated engineering formulas. Help me now to welcome our immediate past president, Wesley Sherwood. The title of his speech, Power from the Sun. All right.
Fellow Toastmasters and distinguished guests, how would you like to have free energy? Wouldn't it be great to turn on your light, turn on your air conditioner, turn on your washer and dryer, and not have to worry about an electric bill? Well, wouldn't you be surprised to know that electrical companies also would like to take advantage of this as well? What you don't know is that electrical companies do pay electric bills. So a lot of electrical companies are very motivated to find a source of free energy. I'm here today to share with you one such method of free energy that is also good for our environment. I'm talking about solar power generation. Solar power generation enables you to make power by using the energy coming from our sun, which makes energy through a chemical reaction. But I promise you, I will describe solar energy without having to go into complicated chemical equations or mathematical formulas. 3 steps I'll be covering tonight. 1 is making electricity with solar. 2, converting electricity made from solar. And 3, it's exporting the solar electricity to customers. In order to make solar energy, you need to have solar panels, or professionally called photovoltaic or PV modules. In order to make a lot of energy, you need to have a lot of panels. What actually happens in the panels is the light from the sun actually creates a chemical reaction leading to the generation of electricity. And a lot of people may believe that the hotter the day is, the more energy you make, and it's actually not true. It's actually on a cooler, cloudless day that you make the most energy. One of the largest power plants that Tampa Electric has produces 75 megawatts, or 75 million watts. 75 million watts is enough power to supply 11,000 homes. And in order for you to generate 75 million watts, Tampa Electric has over 750,000 panels. To understand how big of a plant that you'd have to have for 750,000 panels, it's over 500 acres. However, when you're generating your electricity in a solar plant from solar panels, you're generating what's called direct current electricity, or DC, but what we use in our home is alternating current, or AC. So in order for us to generate the AC that we use in our homes, we use a power conversion station. So what we have with our solar panels is we combine our solar panels together in what's called a combiner box. Apparently there wasn't a lot of thinking involved here. They said combining electricity, let's just call it a combiner box. It is what it is. A combiner box allows you to isolate your solar panels from your electrical grid. The reason you want to do that is because while the sun is shining, there is always electricity being produced by your solar panels. From your combiner box, your electricity goes over to your power conversion station. Your power conversion station consists of an inverter and a transformer. Your inverter is responsible for converting your DC, which is your direct current electricity, to AC, which is alternating current electricity. Alternating current electricity, or AC, is actually changing its energy direction and also its magnitude, unlike DC where it's constant. So here I show you a graph on your left. This is what DC looks like. It never changes. It's just whatever level it is and it's constant. But AC, on the other hand, changes. In order for you to change DC over to AC, we have an inverter. The inverter takes the DC signal and slowly creates different amounts, increasing its level and decreasing its level. So it's not only changing how much power is coming out, but it's also changing the direction, because AC goes in one direction like water going down a river, as opposed to AC, which changes direction constantly. So inside of our inverter, we have a device known as a transistor. And this transistor switches on and off and changes the direction of our DC signal. In order for us to generate a 60 hertz signal that we normally have in our homes, this switch inside of our inverter switches over at 20,000 times per second. I know, it's mind-blowing. I can only imagine how fast that is. With the speed of which this switch switches over your electricity, you end up with what we have here, which is a smooth AC signal. The AC signal leaves your power conversion station and is raised up to a higher voltage. Voltage is equivalent to if you're standing on top of a cliff and you're to jump down. The higher the cliff is, the more potential you have, or voltage. The reason we do that is because when you raise your voltage higher, that power can go for a longer distance. That power is then sent over to the electrical grid, where it's taken over to the substation. And in the substation, that power is stepped up once more again through another transformer up to 69,000 volts or 230,000 volts, depending on how far that energy needs to travel. From that point, it goes over to your power grid and is transmitted to local neighborhoods. At local neighborhoods, you have local substations that reduce that voltage down to more normal levels. For example, a business normally takes power at about 4,000 volts. In your home, it's normally 120 volts or 240 volts. From that point, it goes to the light poles, and then it starts to be distributed to individual homes. And that's how you can use the energy from the sun to create free electricity in your home. Mr. Toastmaster?